Okay, we're going to start talking about spheres, the surface area and volume of spheres. And before we do that, we're going to look at just little bit of the nature of the surface area of a sphere and the volume of a sphere and how those calculations actually come about. Now, often when you take a shape like a prism or a box or a pyramid or something like that, it's really common to take the three-dimensional shape and make a net out of it, where you flatten it out into two-dimensional shape and find the surface area by combining the areas of simple shapes like triangles and rectangles to get the surface area of the entire thing. Now, for a sphere, it's a little bit different because the net for a sphere looks something like this, and that's not exactly the most simple set of shapes in order to actually find the surface area of. You may have seen shapes similar to this when you look at sometimes like certain maps of the globe and stuff like that. Of course, the Earth is almost a sphere, and sometimes you see maps that look like this, and that's where that shape comes from. And it's not exactly made of the most simple little rectangles and squares and that type of stuff to just add up the surface area for. So when systems like computer systems and calculations actually try and find the surface area of a sphere, what they do is they actually sort of use more simple shapes, except they make the shapes really small. And I'll show this. So this first shape here, obviously that is not a sphere, but it's made up of triangles, which you could easily find the area of each triangle. And they're, it's sort of like a pyramid at the top, pyramid at the bottom. So there's 8 triangles in total. And you'd find the area of each triangle multiplied by 18 to have the area of the entire thing. Well, as you can see, as they change the shape, they just make the triangle smaller and smaller and smaller. And as the triangles become smaller, it really approaches the shape of a sphere. And that's how sort of computer systems and some fancy math can do general calculations of the surface area of a sphere, where they just make these little tiny triangles unbelievably small to like infinitely small, which then helps you to find the surface area of a sphere. And that's the basic idea behind it. Like a lot of computer systems, that type of stuff, can do calculations like that. And this is actually a big part of a branch of math called calculus that some of you will take later on in your life. Now, for volume, it can be often the same idea. So I'm going to bring in this picture because this is a great illustration of it. For volume, again, instead of using a perfect sphere, start with boxes. And here, this one's just sort of made of Lego. Now, what you could do is you could easily find out the volume of a little Lego piece because it's basically just a rectangular prism. And what you do is just add the volume of all the little boxes. Now, once again, of course, it's not a perfect sphere, but if you'd make those little Lego pieces smaller and smaller and smaller and smaller and smaller, it would eventually take the shape of a sphere. And that's basically the idea behind calculating the volume of a sphere. You make the boxes infinitely small, so it infinitely approaches the actual shape of a sphere, and then add them up. And again, that's a branch of calculus for mathematics and stuff like that. Now, we end up with the standard formulas for this type of thing. Volume is 4/3 pi r cubed, surface area is 4 pi r squared. That's the basic formulas. But this sort of just gives you a little bit of an idea of what's actually sort of behind the calculations that computers and stuff that do, and some of the ideas behind it. Because of all the shapes, pyramids and prisms and stuff, spheres are actually the most complicated shape because they don't break up into nice little easy shapes to work with that we're used to. It's not even a combination of circles. So it gives you a little idea of where the actual formula comes from, that type of stuff, and you can actually derive it. Of course, it requires more math than we're into right now in grade 10, but that's sort of an idea of where these actual formulas come from.